So you want to know the reaction between the ester plus sodium hydroxide, hydrochloric acid, and heat. So this is a famous reaction that many professors want their students to know. It's called saponification, and this is how we make soap. So just in case you didn't know that, this is how we make soap. But anyway, so what you have is this ester here, and it reacts with sodium hydroxide. So I'll give you what the intermediate product is. So it reacts with sodium hydroxide to give you this intermediate structure here, where you have something that looks like this. Let's go here. So it's not exactly a carboxylate, but it has this sodium group attached to it, okay? Plus, and your CH2, I'll write out, CH3 group is attached to that hydroxyl group, okay? Now, I'm not sure if you wanted the mechanism for that intermediate or not. You didn't really ask for it, so I'm just drawing the intermediate products for you, and eventually to the end product. If you wanted the mechanism, you could request it in another video and I could go through it with you really quick. Doesn't take that long. Doesn't take that long at all. Alright? Doesn't take that long at all. So, in case you wanted to do that, I can. So what do you have is that intermediate where it's sort of a carboxylate, but not technically a carboxylate, because you have that sodium attached to it, okay? Now I'll zoom in so you can see it a little bit better. So now what happens is that isn't a intermediate product that's going to stay like that for long, okay? So what do you have is you have another product where what's going to happen is, remember your HCl that was in solution. I'll draw HCl. Now one thing to keep in mind is HCl will never be in solution as HCl. The strongest acid that can be in a solution is hydronium. So remember that. So really that HCl will actually turn into, once you get it in water, it will turn into H3O plus and Cl minus. Okay, so try to remember that the strongest acid in water is hydronium. Okay, so after that, what will happen is you have a bond right here. So what happens is, I can draw this little mechanism for you. So what happens is these electrons here come off and go on that oxygen. This NaCl attaches the negatively charged Cl minus, and you have something that looks like, let's scoot this over a little bit. You have something that looks like this. Now you have your carboxylate plus the thing that Americans and humans love the most, salt. Alright, and you have your NaCl. And then again, you still have that hydronium ion floating around there, okay? Positively charged. Alright, positively charged. Now what's going to happen next is this here negatively charged oxygen will come and grab a hydrogen off that hydronium. The electrons will go off on oxygen, and finally to the final product, that I'm sure you've been waiting for. And here is the final product, our final product, an acid, okay? And that is our final product. Alright, so If you need any more assistance with the mechanisms, like I said, you could request it in an additional video, but that is a form of a carboxylic acid. All right, so what I'll do is I'll let you kind of look at that in its entirety, but this is the final structure. Okay, this is the final structure that I'm sure that you wanted to figure out. All right, so that is your final structure, and this is how we got there. And like I said, whenever you see NaOH, an ester, an acid, and heat, automatically think saponification. All right, automatically think saponification. And there you go, that's your final structure. So I hope you enjoyed the video. Comment on it under the video. You can like it. I'll put it up on Facebook. Be sure to share it as well.